But what if I have a function which is not a composite function? Will I be able to use the chain rule or not? So let me check it. Let me show you by examples. Example 9. If f of x equals to x to the 5, when you look to x to the 5, it is not a composite function. Therefore, we don't need the chain rule. Remember, if the function is not a composite function, we cannot use the chain rule. The very first condition for the chain rule to be used is that the function must be a composite function. If it is not a composite function like x to the 5 is not a composite function. And then we don't need to use the chain rule. We cannot use the chain rule here. We can simply use the power rule here. So derivative of x to the 5 will be 5 times x to the 4 by using the power rule, not the chain rule. Chain rule is not applicable here. It is not a composite function. Composite function means the composition of two or more functions. If you have the composition of two or more functions, then we can use the chain rule. If it is a single function like x to the 5, it is not the composition of multifunctions. Therefore, we don't need to use the chain rule. It is not applicable here. We can simply use the power rule n times x to the n minus 1. So my answer will be f prime of x equals to 5 times x to the 4. This is going to be the derivative of x to the 5 by using the power rule, not the chain rule. One more example, example 10. If f of x equals to x to the 3 minus 8, again, when you look to this function, it is not a composite function. It is not the composition of two or more than two functions. Therefore, we don't need to use the chain rule. X to the 3 minus 8 is a single function. In case if we had x to the 3 minus 8 to the whole square, then we would have considered the composite function. But right now, it is not a composite function. Therefore, we don't need to use the chain rule. It is not applicable here. We can simply use the power rule f prime of x equals to n times x to the n minus 1. Simply use the power rule. So derivative of x to the 3 minus 8 is f prime of x equals to 3x squared minus 0 by using the power rule, not the chain rule. Chain rule can be only used if the function is a composite function. This is going to be the derivative of x to the 3 minus 8 by using the power rule. One more example, example number 11. F of x equals to cos into x. It is not a composite function. It is different. When you compare this function with cos of x, it is different. This time cos has been enclosed in the parentheses, so it behaves as a constant, and x is a variable. Last time we had cos of x, where x was enclosed in the parentheses. In such situation, cos was behaving as an outer function, and x was behaving as an inner function. But right over here, the case is different. Cos has been enclosed in the parentheses, so it behaves as a constant. This cos behaves as a constant. X is separate. We have the product of x times the constant, which is cos. Because right at this place we have 1. It is cos of 1, not any variable. It is cos of 1, which behaves as a constant. Therefore, we don't need to do the chain rule. As I said, we only need the chain rule if we have the composite function. It is not a composite function. It is not cos of x. It is cos enclosed in the parentheses times x. So this cos behaves as a constant. Therefore, I don't need a chain rule. So I have to apply the normal power rule. Just apply the power rule here. So it equals to cos of 1. And that is the final answer. Cos times 1 is the derivative of cos into x by applying the power rule without using the chain rule, because look, cos behaves as a constant. It is like 2x or 3x. So by applying the power rule, the derivative of x is 1. So 1 times cos is cos. My final answer will be cos. Like the derivative of 2x is 2. Derivative of 3x is 3. Therefore, derivative of cos x is cos. It is a constant, remember. We cannot use the chain rule here.